Hi everyone, welcome to our video on sketching a curve based on given information. We just left off on a video where we did it with this scenario, and if you did watch it all the way, we saw how we went kind of back and forth with our information until we made this conclusion for the graph. And the graph could have variations in answers, but all we really did was make sure at the end to double check all of this stuff actually worked. So we did a lot of preliminary work where we had to cross-reference certain things with each other, but again, double check at the end. Okay, so with this, I don't think there's any quick, direct route to finish these problems. Just take your time and make sure all of this gets satisfied eventually. All right, so let's take a look. So in number 2, we have f of x is continuous everywhere except x equals -1. All right, so this I'm going to mark down right away, and I'm going to start sketching a little bit based on these values. I see 1, 2, 4, -2, so I don't see anything too big. So let's go 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so just to make a grid, and then what I'm going to do at x equals -1, I'm just going to kind of do these dots here. It says it's continuous everywhere, so this I know would be discontinuous at x equals -1. Okay, so just kind of rearranging the way that that's written there would do this for me. All right, and then part B. f of x is differential everywhere except x equals -2 and x equals 1. And this, I'm assuming they are implying, based on this being discontinuous, it's also not differentiable. Let's go ahead and put that. It's also not differentiable at x equals -1. This might get in the way. Hold on. I'm going to put this here. Let's just put it with this guy. Not differentiable at x equals -1 either. If it's not continuous, it's automatically not differentiable. So they might have left that information out on purpose because it's reflected with the continuity. All right, so anyway, so it says f of x is differentiable everywhere except x equals -2 and x equals 1. Since it's continuous everywhere, that means that these two either have a sharp corner, or there's a vertical tangent line, vertical imtan. So it's one of those two that would be happening there. All right, and then let's see what else we got. On C, it says f prime of -2 is undefined, which is also referring to one of these two. It's either we've got a sharp corner, since there is a point there because it says it's continuous everywhere else. So at -2, we either have, let me say instead of sharp corner, let's just say corner. So there's either a corner or, again, a vertical imtan. So this is reflected kind of twice, but we'll see eventually. All right, and then it says f prime of 2 is 0 and f prime of 4 is also 0. So this is telling you that these x values have relative extrema there. Relative extrema. All right, and then f double prime of 3 equals 0. This is telling us that we have an inflection point. Inflection point at x equals 3. Okay, so again, just kind of piecing everything together. And then we see these next three are all about the first derivative. So I'm going to do a star with the first derivative. And then actually, let's go ahead and put a star on all of those. Those all are referencing the first derivative. But with this one, the one that I have currently blocked, that is useful for a number line. So I'm going to sketch that right here. So this is my f prime and my f, and then these are my x values. And I'm just going to mark what I see in these intervals. So it looks like -2, -1, +1, +2, and +4 are all involved in these in some way. And then now all I'm going to do is just break down what's happening with our f prime. So I usually color it in blue. Where f prime of x is greater than 0 means where f prime of x is positive. So in the interval from -2 to -1, our f prime is positive. From 1 to 2, it's positive. And then from 4 to infinity, it's positive. Then it says f prime of x is less than 0, so that means it's negative on this interval, -infinity to -2. So I have a negative there. And then from 2 to 4, that's also a negative. And then this third one is on an interval as well, where f prime of x equals 0 would mean that our slope is 0. M tan is 0. Is this, in another way to say it, M tan is 0, which means we have a horizontal line in this segment. Okay, but with our other information with our f prime, let's color it in red. Remember, where f prime is negative, f would be decreasing. And then where f prime is positive, f is increasing. And then we have a horizontal line. I'm just going to do it like that, horizontal line. And then positive means it's increasing, then decreasing, then increasing. Okay, so there's all that. And then looking at this, well, let's go back. I remember we said something about relative extrema. So f prime of 2 equals 0. So we do have a relative max here. So those are now checking each other off. So right now we could start to check that. F prime of 4 is 0. Yep, it looks like we have a relative minimum there. Okay, so this one is taken care of. Check. Okay, so there we've got our relative extrema. Here it does go from decreasing to increasing, so that probably does mean a relative minimum. And at -2, our derivative is undefined, so that's looking like it's a corner then. So now this, so it's not a vertical tangent, it's a corner. So this is a relative minimum as well. Okay, so now this one is, let's put the check here. And this one is checked off, and then this one was checked. Okay, so all of that's looking good. Okay, and I'm doing the black check to show I'm got lots of things going on that are connecting, and then I'll go with the purple check at the very end to really verify everything. All right, and then still going through this list. Okay, so long process. Our f double prime here, so let's do 2 stars. And that one had a double prime. Let's do that as 2 stars. So f double prime of x is less than 0 on this interval. Well, I've got a number line I can make as well. And we have -2 is important to us. -1's important. 1 is, and 3. And then where f double prime is less than 0, I'm thinking of these two guys. Okay, and I'm not sure about my room. I'm just gonna box them and say if you need more space, draw them somewhere down below. But now that I have these, so these are my x, f double prime, and then let's do the concavity in green. Okay, so I've got my f double prime is less than 0, which means it's negative. So right here, from -infinity to -2. From -2 to -1, and then from 1 to 3. So there's that information. And then my other double star, f double prime of 3 equals 0, means there's an inflection point at x equals 3. Okay, so an inflection point means there's a change in concavity. So that means I do know this will be positive over here because it said the inflection point was important to us. Okay, so that's this information, the inflection point. I know I've got an inflection point right there. Okay, so that means I now know all the concavity. So when it's negative, when f double prime is negative, I know I have concave down, which means it looks like a frown. Here's where an inflection point occurs, so it needs to change from concave down to concave up. And then -1 to 1, referencing our first derivative, I know I had a horizontal line. So I'm just going to put that segment there, and let's put horizontal as in words, just to mark that. Okay, so far we're cooking. Okay, so we have both of our information down for the first and second derivative. And now what I have left is letter J here, where it tells us 2 points. These are nice. Okay, so let's put a check mark on this because we could plot these. These are just regular points. So f of -2 is 0. Okay, so -1, -2, there's my point. And then f of 0 is 3. So there's that point. Okay, so that one's done. All right, and then looking at all this, I think it's looking pretty good. Let's start to see what we can do with our sketch. All right, so it starts off, so I'm using the increasing, decreasing. So it starts to decrease, and then it goes down until we get to -2. Well, at -2, there's a relative minimum, which we've already said is going to be at a corner. So it looks like it'd probably be, so a corner might not be the best. Sharp corner, let's put or cusp in parentheses is what it could happen as well. Okay, so that way we can make sure the concavity is going to match. All right, so it's going downward, and it also has concavity of down, concave down like the frown. Okay, so it's got something like this right there until it hits that point, and let me just put an arrow. So this is decreasing, and it's got concavity downward. Okay, so that's a match, and then it says it's a relative min, and it was undefined at -2 for our derivative, so that's why it's a cusp, and so it would need to increase until we get to -1. And then at -1, it turns into an undefined, or it's not continuous at least there. So that means I would have an open dot. And now let's make sure still everything's going well. So increased at -1, this was going up, so this is looking good. Okay, so, and we can kind of check as we go too. So I said I like to use purple. I'm going to put, so that's looking good. That looks good. We're concave down, check, and check. So concave down, concave down. Okay, so these are all working. And then and then it says it's discontinuous. So that dotted line, again, so if you did it dim, I think it's okay. That just was a reminder. You can just kind of leave that in if you need to. If you want, you could erase these little dots. All right, but we are now looking at from -1 to 1. I have a horizontal line. Now it could be straight from where this one left off. And again, this it could look different. This could maybe be way up here. Okay, so your answer could vary. Because it's discontinuous, I'm just gonna do it somewhere else. Let's just go ahead and put a big dot here. Okay, so this is open. I've now got a solid dot, and then I have a horizontal line from -1 to +1, like that. And then it says after 1 in the red, it needs to go up. And then in the green, after 1, it still needs to be concave down. Okay, so concave down, so something like this would match. Okay, so I've got that so far. Okay, so I've got the horizontal line, check, check. It's going up until it gets to 2, so that's where I'm at 2. And then there's a relative max. Okay, so at 2, I need to turn then. I need to have it turn around. Okay, so at 2 is the maximum, and then it turns downward. All right, and then at 4, so 1, 2, 3, 4. Oh, I have that intercept there, so maybe let's have that go real steep. Okay, so it's going down till it hits there. Let me make that a little better. Okay, so it looks something, so there's the 2, and then it goes real steep, and then it hits that point. Okay, and it's still decreasing, At 3, it does change inflection, so this is an inflection point, so it goes from concave down. After 3, it's going to be concave up. Okay, so it's concave up, but it's still going down until I get to 4. So concave down, or not concave down, decreasing, decreasing, and then it's now looking concave up. Okay, so notice the curve's going concave up. At 4, I have the relative minimum, and then after that, it starts to increase again. Okay, so that means it's got to go up like that. Okay, and then afterwards, so it might not tell us all the information. It certainly looks like it would maybe have another x-intercept based on this having to go up because of the concavity. Okay, so that is looking good. All right, and then I think that's everything. Now let's go through it and see if everything's a match. All right, so f of x is continuous everywhere except at x equals -1. Yep, that's good. Okay, so this one is now officially, A is definitely checked off. F of x is differentiable everywhere except at x equals -2. So that's where it's got the corner. It's also not differentiable at -1. That's good. And then this one, the x equals 1, it looks like it checked itself based on it changing from horizontal. So right here, there is a corner. Right there, that's a corner. So we have a sharp corner. So this one automatically kind of got itself based on the horizontal to what was needed afterwards. Okay, so awesome. So sometimes some things automatically take care of itself. Okay, f prime of -2 is undefined. We already said that that's where the corner is. Yep. F prime of 2 is 0, so that's where there should be a relative maximum. Yep, there is a relative maximum there. And then at f prime of 4 equals 0, that's where a relative minimum is. Okay, so that's good too. And then in letter E, we have f double prime of 3 is 0, so that's the inflection point right here. Yep, we could even, I'm going to mark it and say, well, that is concave down, and then afterwards it does look like it's concave up. Okay, so I'm just going to mark this. That is an inflection point. Just to be clear, because sometimes it's tough to tell where the inflection actually occurs, so I'm going to say it in words, but now it is definitely checked. Now, all of this in the bracketed star was our first derivative information. One more time going through it, it goes down until -2, yep, and then it goes up till -1, yep, and then a horizontal line until 1, yep, and then it goes up till 2, yep, that's a check. And then from 2 to 4, it's downward. Yep, that's good. And then from 4 to infinity, 4 onward, it's going upward. Yep, check. Okay, so that's looking good. So all of this is checked based on this number line. And then in our blue number line, we want to check the concavity. So concave down, yep. And then from -2 to -1, concave down, yep. -1 to 1, horizontal. From 1 to 3, that's that portion that is concave down, And then after that, it's concave up. Okay, awesome. All of that is good. Check. And then the 2 points, f of -2 is 0, yep. F of 0 is 3, yep. Okay, so, and our answers could vary. All right, so it doesn't have to look exactly like this. But it's something like that. All right, so everything does just check you just have to check everything, make sure it's working, and verify. Just double check. That's all it is. Okay, so and that sounds easy. That's all it is. No, it's not easy. It's a long process. So go through it. Really, it's a lot of referencing back and forth of certain things. Okay, so if we make a mistake on referencing something, that's okay. These should eventually catch it anyway. And then from there, we should hopefully be able to make that adjustment. All right, so that is all. If you have any questions, please let me know. Otherwise, thank you for watching, and I'll see you next time.